is negative 3 t squared dt. What is this equal to?
Oh, sorry, du.
Excellent. We're done. We accounted for everything. All pieces are already accounted for. And now, again, this is e to u plus a constant c. Done. But I have to now, in step 4, if you'd like, replace u. So negative 1 over 3 e to u, which is negative t to the third plus a constant c. And this is it. So we changed a complicated integral into a simple one. Simple. We solved this one in a blink, and then we replaced u with the substitution that we made. Next one, please choose. Anything, as long as it's still indefinite. Anything from 1 through 42 are all indefinite. Yes, some of them can be a little bit more difficult. Will anyone choose, or I will?
Can we do 23?
23 it is. Very good. Very good one. The integral from dx over 1 minus x. Good. Excellent. So first of all, I don't like this form. The polynomial in the denominator is not arranged in the correct order. This is the correct order. And now I don't like the fact that it has a negative leading coefficient. Not a problem. So then the integral is basically negative in front dx over x minus 1. Remember, what is dx over x minus 1? It's the same with 1 over x minus 1 times dx. Same thing. This is what I don't like. This is a function inside of 1 over x. I want 1 over x. I don't want 1 over x minus 1. So I'm going to say in step 1, let u be x minus 1. I want it simple. I want just 1 over u, which I know how to handle. In step number 2, I have to find du. Can anyone give us the du for this function? What is the derivative of x minus 1? Good. But since this is du, I don't have to write 1, but I'm going to write 1 just for now. 1 times what?
Dx.
Exactly. Awesome. It cannot be easier. Du is dx. So in step 3, I finally continue from here. Negative in front. I don't have to make any adjustments. I don't need to multiply, divide by anything. It's the integral from the top, dx is du. And the denominator, which is x minus 1, is u. Done. So now I have minus. What function prime is 1 over u?
ln?
Excellent. ln of the absolute value of u plus a constant c. Great job. Minus, I have no choice, but plug it back in. U is x minus 1 plus a constant c. Done. Very good pick. Can we do 30 or 32? There are other methods for this. They will be slightly more difficult and more involving. But if you're taught a different method, I'm fine with it. So 30 or 32, any preference? Or, or both? Okay, 30. Let's start with 30. Okay, the integral from e to t dt divided by 3 plus e to t. Okay. Step 1, we let u be something. What would you let u be? And why?
Did you say 3t e to the t because
Oh.
it's in the
Yes, of course. I don't like denominators like this because I cannot split them, I cannot simplify them, that's it. Now what is du? What is the derivative?
e to the t.
Very good. Times.
D dt.
That's it. Piece of cake. Look at this. Is du. So the integral from du over u. This is our u and this is our du. Nice. We're back to the previous example. I'm going to move on to the next page. So how would you write the final answer? Which function prime is 1 over u? You just told me a minute ago. Natural log of the absolute value of u plus a constant c. And that's it. Now I have to go back to the substitution. 3 plus e to t plus a constant c. Done. Any questions? Any questions? Can we look at also at 32 now? And then definite integrals? Or you want to choose another? Once you understand the method, it's going to be a piece of cake.
Can you do 31?
Yes, 31. So the integral from natural log of x squared divided by x dx. Perfect. Good. So let's use a substitution. Let u be what do you think? X is nice. It's okay, I cannot do anything. This is just a simple. I will not ever denote u by x. That's not going to change anything. It's not going to do anything. So what else could we look at? You could say, I don't like x squared inside of natural log. So I'm not going to erase it if that's what you want. We can do that. So we can consider, also I wanted to say, sometimes there is more than one path to success, right? So I may find a substitution, you may find a different one, we get to the same result, and it's possible that one is easier than the other. But we can still get use different substitutions and still get the same answer. So you could say this. You could also say u equals natural log of x squared and see what happens. The substitution is good as long as we can find du. If I cannot find du and put it in the problem easily, then I'm not on the right path. So let's analyze these two options and see what happens. If I use this substitution, what is du? Anyone?
2x.
careful, this is not the derivative. This is du times dx. I will have a hard time with this. The 2 is not a problem, 2 and 1/2. But how do I get an x in the numerator to be attached to dx? Okay, so that doesn't really take me where I want to go. Let's try this one now. Let's try the derivative and du of the differential of u for the function natural log of x squared. Let's see what happens now. What is du for this function? We differentiate natural log. What is the derivative of natural log? There is a way for this one too, but it's a little bit more complicated. Can anyone differentiate natural log of x squared for us? Anyone? It's 1 over x multiplied by the inner function prime, which is very good, and multiplied by, because this is du, not u prime, multiplied by so is it clear that every time you find du, you have to have dx, or if you find dt, you have to have dx? You have to find whatever d here has to have a d here. Is that clear? Is it?
Yes.
Perfect. So now I simplify these two, and this is what I get next. Du 2 dx over x. Ah, look at that. 2 and 1/2, 2 dx over x, 2 dx over x. These three pieces will be replaced by du, all these three. And then what am I left with? So I have 1/2 in front. What is natural log of x squared? Look at our explanation and tell me what would you replace that by? Do we have natural log of x squared? Anywhere here. Natural log of x squared. What do I replace this piece by?
U.
Very good. And what do I replace again? 2 times dx over x. What do I replace this by? 2 dx over x. By?
U.
That's it. It cannot be easier. 1/2 u squared over 2 plus a constant c. Or 1/4. Now u has to be replaced. Plus a constant c, and u was natural log of x squared. Very good pick. Can we switch now to definite integrals? These were all indefinite. Do we feel a little bit better about the substitution for indefinite integrals? Is that a yes? Is that a no? Do we need more?
It's still a little tricky.
Right, but once you review this and you redo them, you're going to feel so much better. I highly recommend we do these problems first before you do anything. So let's look at definite now. Definite integrals with substitution rule. With substitution. I'll choose the first, you choose the next. Okay, 46. This is different because this is a definite integral from 1 to 2 from x squared minus 1 to the 7th dx, and the answer would be a function or a family of functions or a number.
This one should be a number.
Excellent. It's a definite integral. It will be a number. Excellent. Thank you. Good. Steps. First steps are the same. So let's let u be, and you tell me what would you let u be?
X squared minus 1.
Of course. That's what bothers me. This bothers me. Inside power 7. But in step 2, I have to have du. So what will du equal to?
2x dx.
Excellent. Is it in the problem? Yay, it is. So right here, here's the x and here's the x, both. I don't have a 2. Not a big deal. I can multiply by 2 and divide by 2, and I didn't change anything. So now, from here, in step 3, if you want, we have 1/2 in front, and please do not copy the limits of integration, but tell me how will you change the integral now? Everything is accounted for. Tell me, what should I write? Take your time and tell me what I should write.
U to the 7.
So,
du.
excellent! U to the 7 to u, of course. Because this is u to the 7 and 2x dx, 2x dx is du. Awesome! This is here, this is here. This is this, 2x dx, 2x dx, all accounted for. And this is the u to the 7. Everything is accounted for. However, there is one difference now. The interval is from 1 to 2 when x is 1 and when x is 2. So, because the integral now is in terms of u, I can no longer copy 1 and 2 because these are the limits for x. Now I have to create new limits of integration for u. Very simple. For the lower limit, I plug in 1. What do I get?
0.
Excellent. To find the upper limit of u, I plug in 2. What do I get?
3.
Excellent. We're not going back. Notice what we did for all indefinite integrals. We had to go back to the original variable. No longer true now. There is no need to do that. So I have 1/2 u to the 8 over 8 from 0 to 3. We do not go back for the definite integrals. Waste of time. It's a number. It doesn't care whether the number is obtained using u or x. So this will be 1 over 16 times 3 to the 8th power. And when I plug in 0, nothing happens. So what do I get? 3 to the 8th power. So this is 6561 divided by 16. That's the difference between the two. For the indefinite integral, I must present the answer in the variable given in the problem. X dx, right? X. But here, who cares? If I obtain the answer using x or I obtain the answer using u, who cares? It's one number. It will be the exact same number.